Imagine a world devoid of motion, a place where everything stands still, frozen in time, no wind rustling through leaves, no gentle breeze to sway the branches, no waves crashing on the shore, no rhythmic dance of the ocean meeting the land, no graceful arc of a ball in flight, no sense of momentum or energy. This static existence is far removed from our own dynamic reality. Our world is in constant motion, filled with energy and life. Now imagine bringing that same lifelessness to the world of 3D animation. Imagine characters that don't move naturally, scenes that feel empty and devoid of life. Characters would move with an unsettling rigidity, their motions mechanical and unconvincing. Objects would interact without consequence, colliding without any real impact or reaction. The illusion of life, so carefully crafted, would crumble. The magic of animation would be lost, leaving behind a hollow shell. This is where the power of dynamics comes in. Dynamics breathe life into the digital world, making it vibrant and believable. Dynamics in 3D animation is the art of simulating real-world physics within a digital environment. It's about creating a sense of realism that resonates with our understanding of the physical world. It's about breathing life into pixels, giving objects weight, and imbuing movements with a sense of naturalism that resonates with our own experiences. Every motion, every interaction is crafted to mimic the real world. From the gentle sway of cloth to the explosive impact of a demolition, dynamics play a crucial role in making these scenes believable. Dynamics transforms the impossible into a captivating illusion of reality. It allows us to create worlds that are both fantastical and grounded in the laws of physics. This is not merely about aesthetics, although the visual impact is undeniable. It's about creating a world that feels real, that draws the viewer in and makes them believe in the story being told. Dynamics add a layer of believability that draws the viewer deeper into the narrative. They make the impossible seem possible, the fantastical seem real. When done well, we forget we are watching computer-generated imagery. We become lost in the story, immersed in the world that has been created. We become immersed in a world where the laws of physics, even if subtly bent, still seem to apply. This is the magic of dynamics in 3D animation. It bridges the gap between the real and the digital, creating a seamless experience that captivates and engages. As technology advances, the potential for dynamics in 3D animation continues to grow. We're on the brink of creating even more realistic and immersive experiences, pushing the boundaries of what is possible. The future of 3D animation is bright, filled with endless possibilities. With the power of dynamics, we can create worlds that are more vivid, more engaging, and more lifelike than ever before. So the next time you watch a 3D animation, take a moment to appreciate the dynamics at play. Notice how they bring the scene to life, how they make the characters move and interact in ways that feel real and believable. It's a testament to the skill and creativity of the animators and the incredible power of dynamics in 3D. This is the magic that transforms pixels into living, breathing worlds. Physics is the language of the universe. It is the fundamental framework that explains the natural phenomena we observe every day. From the grand scale of galaxies and stars to the minute interactions of subatomic particles, physics provides the rules that govern everything. It governs the motion of planets, the behavior of light, and the way energy is transferred and transformed. When light passes through a prism, it bends and splits into a spectrum of colors, a phenomenon explained by the principles of refraction and dispersion. At the smallest scales, physics describes the interactions of matter, from the bonding of atoms to form molecules to the complex behaviors of particles in quantum mechanics. These interactions are the building blocks of everything we see and touch. It's a universal truth that transcends the boundaries of our world and extends into the digital realm. In the world of animation, these principles are not just theoretical, they are tools that bring digital creations to life. By incorporating the principles of physics into 3D animation, we tap into this universal language, creating a sense of familiarity and realism that resonates with our deepest understanding of how the world works. This connection is what makes animations feel alive and believable. Think about a simple action, like a ball bouncing on the ground. This seemingly mundane event is a complex interplay of forces and energy. We intuitively understand how gravity pulls it down, accelerating it towards the ground. This force is constant and predictable, a fundamental aspect of our physical world. Upon impact, the ball deforms, compressing under the force. This deformation is a result of the material properties of the ball and the energy of the impact. The energy is then transferred back, causing it to rebound. This transfer of energy from kinetic to potential and back to kinetic is a fundamental principle of physics. These are all principles of physics in action. They are the rules that govern motion, energy, and matter, and they are essential for creating believable animations. In animation, we recreate these principles using mathematical equations and algorithms. These tools allow us to simulate the physical world with remarkable accuracy. We simulate gravity, momentum, friction, and countless other forces, each contributing to the overall realism of the animation. These simulations are not just about making things look right, they are about making them feel right. This allows objects to move and interact in a way that mirrors our own physical world. When we see an animated object behave in a way that aligns with our understanding of physics, it creates a sense of immersion and believability. This isn't about replicating reality perfectly. Animation allows for creativity and exaggeration, but the underlying principles of physics provide a foundation that makes even the most fantastical scenes feel grounded. It's about capturing the essence of how things move and behave, creating a sense of believability that enhances the storytelling experience. This believability is what draws viewers into the story and makes them care about the characters and events. By understanding and applying the principles of physics, animators can create worlds that are not only visually stunning but also emotionally engaging. The interplay of physics and animation is a dance that brings stories to life, making the impossible seem possible and the imaginary feel real. Imagine playing a video game where your character could walk through walls or objects, phase through each other without consequence. The illusion of a solid, interactive world would be shattered. This is where collision detection comes in. It's the unsung hero of animation, ensuring that digital objects behave as they should when they come into contact. Collision detection is the process of detecting when two or more objects in a 3D environment intersect. It's a complex computational problem, especially in scenes with a large number of objects or complex geometry. However, it's crucial for creating a believable and interactive experience. Think about a simple animation of a character walking across a room. Collision detection ensures that their feet collide with the floor, preventing them from falling through. It also allows them to interact with objects, pushing them aside or knocking them over, just as they would in the real world. Without it, our digital worlds would be chaotic and nonsensical. Section 4. A universe of particles simulating the untamed elements. Some of nature's most mesmerizing phenomena, from the billowing smoke of a wildfire to the crashing waves of a stormy sea, seem almost impossible to capture in a digital world. This is where particle systems come in, allowing animators to create complex and organic effects that would be difficult, if not impossible, to achieve with traditional animation techniques. Particle systems work by simulating the behavior of a large number of small independent particles. Each particle is governed by a set of rules that determine its movement, appearance, and lifespan. For example, to simulate fire, particles are emitted from the source, rising upwards due to buoyancy. Their color shifts from yellow to orange to red as they cool, and they eventually fade away, simulating the dissipation of smoke. By tweaking the parameters of the particle system, animators can create a wide range of effects, from gentle smoke trails to raging infernos. Section 5. The Dance of a Thousand Strands, the intricacies of hair dynamics. Hair, with its individual strands that respond to gravity, wind, and touch, presents a unique challenge in animation. Each strand must be meticulously animated to mimic the natural behavior of real hair, which is influenced by a myriad of factors. Traditional animation techniques often struggle to capture the natural flow and movement of hair, making it look stiff and unrealistic. This is because traditional methods rely heavily on manual keyframing, which can be incredibly time-consuming and often fails to replicate the subtle nuances of real hair movement. However, hair dynamics, using physics-based simulations, have revolutionized the way we animate this complex feature. These simulations allow for a more natural and fluid movement, as they take into account the physical properties of hair. Hair dynamics treat each strand of hair as a chain of connected particles or points, each influenced by gravity, air resistance, and collisions with other strands or objects. This particle-based approach allows for a more accurate representation of how hair behaves in the real world. This allows for incredibly realistic hair movement, from the gentle sway of a ponytail to the wild strands whipping in the wind. The simulation can adjust to various conditions, whether it's a calm day or a stormy night, providing a dynamic and lifelike experience. However, achieving this realism comes at a cost. The complexity of simulating thousands of individual hair strands requires advanced algorithms and significant computational resources. Hair simulations are computationally expensive, requiring significant processing power and time to calculate the movement of thousands, if not millions, of individual strands. Each strand's interaction with its environment and other strands must be meticulously calculated to ensure realism. Animators must carefully balance realism with performance, optimizing their simulations to achieve the desired look without sacrificing render times. This often involves making trade-offs between the level of detail and the computational resources available. To manage these challenges, animators use specialized software that allows them to tweak various parameters of the hair simulation. These tools enable real-time adjustments, helping animators find the perfect balance between visual fidelity and performance. By optimizing hair dynamics, animators can create stunningly realistic hair that enhances the overall visual experience of the animation. The difference between a well-optimized hair simulation and a poorly optimized one can be striking, affecting the viewer's immersion and the animation's believability. In the end, the intricacies of hair dynamics play a crucial role in bringing animated characters to life. The effort and resources invested in perfecting hair simulations are well worth it, as they contribute significantly to the realism and emotional impact of the animation.